Okay, so here are the independent and dependent events. So on your fill-in notes, your video notes, you've got, here's your definition of independent events. They don't affect the occurrence of another event. So reading further, you'll notice that your conditional probability of these two events equals the probability of A. Here, when you've got A given B. So also, if you have B given A, then it would equal the probability of B. Because your conditional probability, A is going to be unaffected by B, so it's going to equal to your probability of A. So let's dive into looking at one of our two-way tables. So if you look here at 180 randomly selected flights, let's find this probability. If you've got an event that a flight is on time, is it independent of the event that a flight is domestic? So let's look. We're going to find the probability of it being on time. We're going to go with a slash just to save time for typing. Given that it was already domestic, equal to the probability of it being on time. So, looking at that, your probability of the conditional probability, if we're going to look at it being domestic, it's already domestic. You've got 120 of those flights. And within those domestic flights, on time is 108. So we've got 108 out of 120. All right, now let's look at what is our probability of on-time flights. All of our on-time flights, we have 162 out of a total of 180. If we crunch these numbers, you're going to find out that you've got 90% of your on time out of domestic flights, and this is also 90% for your on-time flights. So this shows you that you do have independent flights, it being on time versus it being an on-time domestic flight. So this is an independent event. Now let's check the next part. Is it independent if the flight is international of the event that it's arriving late? So remember, I'm taking a shortcut with the notation, so be careful. I do not want you to do this as you're writing your work. It's that vertical slash. So we've got the probability of an international flight, given that it's already late, is it equal to the probability of international flights? So let's look. If it's already late, all of our late arrivals, we got a total of 18 flights. How many of those are international? We got 6 out of 18. Not 8. And let's look at our international flights. How many total do we have there? We have a total of 60 international flights out of 180 total flights. So if you look right here, I hope that you can see that these are going to reduce to the same amount. If you crunch this, you get 33% for both of these. So these again are independent events. So you want your conditional probability to be equal to a single probability because your probability of the B already having occurred does not affect your single probability. All right, so checking or finding probability events, independent events, your intersection of those two events separately, if you multiply them together, is going to equal your intersection. So if you look at this jar that's got red and yellow marbles, 15 red, 17 yellow, this is going to be something called replacement. If you randomly draw one marble from the draw jar and then put that marble back before you draw your second marble, that's called replacement, because you put the marble back after you drew it. What is the probability that you draw a yellow marble first and a red marble second? Okay, well, what is the probability of drawing that yellow marble? Well, you have 17 out of 32 total marbles, and you are going to multiply that by that first marble that you drew is back in the jar. So what is the probability of drawing a red marble? Well, that would be 15 out of 32. And once we multiply those two together, what you get is 255 over 1024. It's going to be equal to about 25%. So you've got a chance of 1/4 of getting first yellow and then red. So 1 in 4 chance, roughly. Okay, so we know what we're going to get as far as the intersection of two independent events and how we know that they're independent. We're going to do the conditional probability equals the single probability. So those are kind of tests for knowing if we have independent events. So here we go. You got two tests for the independence of events A and B. So if either of these do not come out equal, so if our conditional probabilities does not equal our probability of A in A given B, or if our intersection does not equal our two separate probabilities, then we have what are called dependent events. So let's take a look at this survey of 100 people. So we've got males and females who either like walking on a treadmill or walking outdoors. Let's check these two events. We've got O is somebody who prefers walking outdoors, and M is that person is male. So let's see if those events are independent or dependent. So if we do the probability of O and M, so remember A and is your intersection. So what would that be? All of our events, we've got 100. Where they intersect, you've got a male who prefers walking outdoors. Where is that at? You've got 40. So this is 40 out of 100. That's our intersection of those two events. Okay. Well, what is our probability? Let's do the probability of O, and then we're going to multiply that by the probability of M. All right. What's the probability of somebody who likes to walk outdoors? Okay. How many people like to walk outdoors? We have a total of 60. So we've got 60 out of 100. And we're going to multiply that by what is our probability of men. Okay, so we've got males. We've got a total of 50. Okay, so if I multiply that together, I'm going to get a very large number. So 30,000 over, is that 10,000? More than that. It should be 3,000. 3,000 over 10,000, which is going to come out to 3 out of 10. All right, 3 out of 10 is definitely not equal to 40 out of 100, which would be 4 out of 10. So since these are not equal, that means it failed that test. So we have dependent events. All right, and then down here, so we know how to check for it being dependent. We could have done that test, or we could have done here. We could have checked our conditional probability. So you can choose either one of those to do. Let's see. So right away we can see this conditional